Engineer Joy M. Shah. I welcome you on behalf of BVM Engineering College, Civil Structural Engineering Department and Women Development Cell, BVM Engineering College. I congratulate you, sir, for doing such a good activity in the area of energy and environment. This energy and environment are high priority areas. Both need utmost attention. Energy efficiency programs are for best practices. How can we save energy, which is a very scarce resource as far as our country is concerned? And environment conservation is a global problem, very important looking to the climate change. The engineer have to know about these two areas. They should not be unknown about this. Women Development Cell, Structural Engineering, Civil Engineering team is doing this webinar. I congratulate them for such a good webinar. Civil and Structural Engineering department came into existence when the BVM engineering came into existence in 1948, around 72 years. Civil Structural Engineering department has well qualified faculty members. They are having very good experience. They are involved in research and consultancy services. Civil engineering and structural engineering department is having 5 postgraduate programs. The civil engineering program has been accredited since 2013, and BVM Engineering College is having 8 undergraduate programs and around 13 postgraduate program, and now going to start PhD programs. So there will be great opportunity for research in this area. So we are having the first autonomous engineering institution run by Charutar Vidya Mandal, and around 20,000 engineers have been groomed and they are working at local, national and international level. So sir, I welcome you in such a good institution to make your presentation. I wish a very good learning to all dear participants into this program. Uh, Thank you.
Thank you very much, sir. Now I would request Dr. Reshma Patel ma'am to welcome our today's expert, Dr. Joy M. Shah sir. Ma'am, you are muted.
Welcome, sir. I, Dr. Reshma Patel, take this privilege to introduce the eminent personality in the field of chemical and environmental engineering to our esteemed audience. Sir, you are Vice President, Head Technology at Reliance Industries Limited, having experience of around more than 35 years in petrochemical industries as a team leader and head of various functions of petrochemical complex. You were chemical engineer topped in the list of the success candidate from Gujarat University in 1982. You are also fellow member of Institute of Cost and Management Accounts of India and fellow member of Institute of Engineers, life member of Institute of Chemical Engineers as well, certified energy auditor and lead assessor for green company certification. You have contributed to the growth of Hazira Manufacturing Division of Reliance Industries Limited from the inception to its present day eminence and pursued all the plants run at their best efficiency and capacity. You have headed the technology function, energy and fuel cell, as well as quality assurance and quality control function for 6 years at Hazira Integrated Complex, consisting of 26 number of world-scale petrochemicals, polymers, and polyester plants. You have also commissioned the leader for 3 numbers of large-scale petrochemical plant. There are several cost reductions, value additions, and productivity as well quality improvement screen proposed and executed by you, bringing net contribution to the Reliance Petrophil portfolio by a few hundred crores per year. You are instrumental in getting several awards for excellence in energy management, sustainability, product development, and quality management from Hazira Manufacturing Division. You are chairman of Process Safety Management Committee, leader of Risk Management Committee, champion of intellectual property management while working with Reliance Industries Limited. At present, you are co-chairman of Industry 4 Committee of SGCCI, member of Safety Committee of Indian Institute of Chemical Engineers, EC member and student chapter of IICHE, ARC, advisor and jury member for conference and award of IRPC and CII. From May 18, you are practicing management consultant for sustainable manufacturing and operational excellence to chemical, hydrocarbon, and polymer industries at Inno8 Protech Solutions. Your area of expertise are energy, water conservation, process safety, and risk management, petrochemical technology, process engineering, and cost leadership. Over and above, I highly acknowledge your concern for the environment, sir. Frequently, I am reading your post on the social media regarding your high concern for the protection of the environment as well as your worries for the climate change. I would like to inform to the esteemed audience that sir has still just cleared the first phase of the ICCC challenge. That is not the World Cup, but International Climate Change Challenge, and he has entered to the second stage. On behalf of Civil Engineering Department, sir, I welcome you. Thank you.
Thank you very much, ma'am, for such a brilliant introduction. Now I would request Dr. Joy M. Shah, sir, to start his session.
Good afternoon, everyone. Thank you very much, Dr. Reshma Patel and Mr. L.B. Zala for my introduction to the students. The mentoring of the student is always at heart to me, near to me. And I used to mentor a lot of GETs at Reliance and now also in and nearby Surat, Ankleshwar and Bharuch. I am mentoring some of the chemical engineering students and the colleges, and that is my passion. So when I was asked that I should present to you on some subject on the energy and environment management, I was very happy. And I was told that most of you are from environment and civil area. So I thought that let me focus my presentation on environment and civil area, so it is useful to you. And my first purpose of the whole presentation will be to make sure that you start taking interest in this area, so that you you start learning and taking interest, so that the future of the India is bright. You are able to see my screen?
No, not yet, sir.
Just a minute. Now the screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, start, right? So, dear students and the professors, in fact, energy and environment management was my passion when I was working with Reliance, and I did a lot of work in the energy and environment management. So now after retirement from Reliance, I started practicing on these two areas, which is very near to my heart. And it is my pleasure to inform you about some glimpses on various aspects of the energy and environment management, especially related to the building and the civil engineering. You know, civil engineering raw material is the largest energy consumer. In fact, let me tell you that you will be able to post your answer to the chat box and I will be able to see those answers. So I will ask you a few questions in between, which are very common nature and very common sense type of question, just to understand that what is your present level of understanding so that we can go into detail. You know, what are those two raw material for the civil engineers which are the most environment which are producing the most carbon dioxide and affecting the environment? Can you write down a couple of raw material for civil engineers? Students. I am not able to see anything in your. Yes, very good. Very good, Miss 323. Cement is one of the most raw material which produces the maximum amount of carbon dioxide. But I am very happy being in India. You know, cement industry in India is the least carbon dioxide generator because cement industry in India is using a lot of waste material which as such is supposed to produce a carbon dioxide. So if you see the world benchmark, the energy consumption or the GHG emission from the cement industry in India is the minimum. So that is the good thing that I would like to tell you. Which one is the second? Second raw material, which is the largest CO2 emitter. Can you? Yes. Once again, 822. I'm not able to see your name, but 822. Steel is also a very large CO2 emitter. But unfortunately, Indian steel industries are very old steel industries. The technology is not very good or very latest technology. And still the CO2 emission or the pollutant emission from the steel industry of the India is still very high, and a lot of things need to be done on the steel industry. Now, one more thing. Can anybody tell me that which area the maximum CO2 emission is taking place? If you see the total life cycle, which area of this world the maximum CO2 emission is taking place? Any idea? Industrial area, burning of fossil fuel. It is good. It is true. Some more thought from you. Say the maximum CO2 emission is taking place from the building area. Almost 40% of the energy used in the world is in the building area. So you are designing the building and perhaps you are the front runner for curbing the CO2 emission, and that was the reason why I thought of that. Let me take, although my area is chemical engineering, let me take this awareness lecture to the civil engineers. So the building is one of the area which need a lot of focus and attention for reducing the CO2 emission. Now let us go to the next one. So what do we do? So after this retirement, I started consulting to some of the chemical and high hazard industries. So we give some consultancy on the process design. We give consultancy on the process safety and risk management. Energy and water management is one of the prime area for all of us to reduce these footprint, carbon and the water footprint, environment and waste management, cost and quality leadership, capability develop. We provide a lot of training to the industries people for their developing their capability in these 5 areas. And we carry out assessment and verification, as well as we study their business process system and try support them in providing the industry 4.0 option for that industry for making it more sustainable. And ultimately our target is sustainable manufacturing and operational excellence. Okay, I think this slide has not come, right? So these are all 8 areas we work for the industry. Now what shall we learn today? So number 1, what is the climate change and why we all need to act for that? As Professor Zala said that all of us have to act. So why we need to act? Unless we know the reason, it will be difficult for us to act fast. Second, we'll see some of the best practices for energy efficiency. I'll try to focus on the building area and then just give some glimpses on the industry area. Third thing, we'll see the government policy for energy efficiency. You know, there are a lot of initiatives are being taken by the government for energy efficiency as well as reducing the carbon footprint. So we'll just touch on the government policies. Then we'll touch on the building sector best practices, industry's avenue for the energy saving. So that is the area where we'll just touch on, because this is a very vast area and it requires a lot of debate, deliberation and understanding. And then I will give you a few example of the net carbon positive system. Now I'll ask you some question. You know what is climate? Can anybody tell me what is climate? Okay, let me show you the picture. Perhaps that will bring some more knowledge. We always say weather is not good, but few people say climate is the problem. It is climate is a challenge for us. So can you tell me what is the climate and what is weather? Anyone?
Hello, sir.
Yeah.
Climate is an atmospheric condition which include rainfall, humidity, meteorological elements, and weather. It defined as atmospheric condition at a given particular time, I think.
Yes, very near to the definition. And any more ideas?
Hello, sir.
Yeah, tell me.
Weather is the daily condition of the atmosphere that is recorded for a short period of time.
Okay.
And climate is the weather that may persist for a longer period of time. It is recorded for about 35 to 40 years of time of a particular area.
Very good. Perhaps you are almost near to the definition. Say climate is a long-term average of daily weather. A standard period of 30 years is taken. In the world, almost there are 30,000 points where the temperature and other climatic condition is monitored, and it is averaged out and it is published almost every month. What is the change every month? So that is the climate. And weather is what we say. Today we say there is today's atmosphere. So our AccuWeather and other thing what they are giving us, that is the weather. So weather is not a constant, it is dynamic. It always changes. But climate is an average of the 30 years taken for calculating the climatic average. So you are very near to the definition. My compliments to you. Let's go to the next. What is climate change? What is climate change? Anyone can give some definition?
Seasonal variations.
Okay, some more. I'll give you some example. You might have heard some of the conferences name like Montreal Protocol or UNFCCC or IPCC. All those names are very, very popular or well known. It is appearing in many newspapers, social media, and other. Kyoto Protocol are appearing, right? So all those things are focusing on the climate change. So what is climate change?
Sir, large scale shifts in the weather pattern we can define as climate change.
Yes. So
and I will give the today's example. All of a sudden, in the midst of sunny day, there was a heavy rainfall. Well, there was a trial which was going on around 10 o'clock in Vidyanagar. One of the examples.
Right. You're very right. So climate change, say IPCC is defining any change in the climate over the time. So what we said, 30 years. Over 30 years, suppose if there is some change in the climate, and due to natural variability or as a result of human activity. So temperature going up, then various other weather incidents are taking place, like that we'll come to know at a later stage. So that is what climate change we say. And we definitely observe some climate change. UNFCCC have defined the climate change not only human activity. This is either natural climate variability observed, maybe because of the nature also climate variability is observed, or it may be because of the human. And whatever is long-term trend is visible, that is what we call climate change. So, and these all climate change is identified by some statistical testing. It is not like someone is saying and we are saying. There are almost 30,000 points where all this data is checked, measured periodically, and then statistical analysis is done and averaging is done. So what will happen if climate change is taking place? Perhaps we have seen, right? We have seen in last 3-4 years, 5 years, something is happening in the world. So people are saying glaciers are melting, right? So when the climate change is taking place, we always say there is some global warming is taking place. The temperature is increasing, leading to the melting of glaciers, right? So is the melting of glaciers is only the thing? Will it stop someday? In my opinion, it will not stop, because when glaciers are melted, it contains a lot of greenhouse gases that is also released, and that is again this spiraling effect, and it will further lead to the warmer and warmer weather. What more? Floods. You might have seen Amphan and other cyclone flooding in several areas. unseasonal rain. Why it is happening? You know, last 10 years, the sea level has been increased by almost a half feet. That is one of the reason. And there is a very heavy rain in some of the areas and drought in other areas. So that led to the change in the say pattern and change in the various agricultural seasons. That also led to change in precipitation pattern. Means somewhere it is heavy rain, somewhere it is very light rain or drought. So that those all things, some in US perhaps you have heard about the forest fire. That is also impact of climate change. Here in India you might have heard about a couple of cyclones recently, or US few cyclones recently. That is also the impact of climate change, because weather is warming up and it is affecting the complete cycle of the earth. So the rain pattern is changing, agriculture pattern is changing, food security will always be a question when we have the climate change. And then ultimately we, all of us, have to work on it. Unless we all work on it, it will not be returned back. And one thing is, recently in COP Paris meeting, what has been discussed, that if you do not restrict at certain temperature rise, then it will be irreversible. And once this study was released, people's eyes got opened and they started working very heavily. So it is expected, if we do not do anything, the sea level will rise by almost 4 feet by 2100. So 2100 is 80 years from now. Okay, and 4 feet is too high. Maybe a lot of cities will be under water. So you will always think that why the climate change? The only thing people can think of is because of the carbon dioxide is increasing, that lead to the climate change, isn't it? Or you have got any other idea or any other thought that other thing is also responsible for climate change?
Sir, one of the most neglected sector, which is responsible above all, is the agricultural sector. In the race of feeding the human population, around 8 billion in the world, we have neglected this sector for green revolution. But oxides of nitrogen produced from synthetic fertilizer is the greatest cause for ozone layer depletion. And that is one of the major cause, I suppose, for climate change.
Very true. Yes. So apart from industrialization, change in the pattern of agriculture, use of the lot of synthetic fertilizer, use of various natural gas, methane emission, and waste generation, which also produces methane. These are all the reasons for the climate change, right? So it is not only CO2, but there are many other gases we'll come to know. And these all gases are called the greenhouse gas. And whatever effect we are seeing in the climate change is the effect of the greenhouse gas effect. Now you tell me, which one is the hottest planet in the world, in the universe?
Venus. Venus.
Very good.
Venus.
Why?
Because
why Venus is hottest when something else is nearby the sun?
Mercury is near to sun, but Venus actually does not have the atmosphere, and Mercury has. So I think the atmosphere, the lack of atmosphere in Venus makes it very hot.
I don't think it is the lack of atmosphere, but it is presence of atmosphere which is very dense in nature. Therefore, it traps all the energy inside and it becomes hotter and hotter as compared to Mercury.
Very near to the answer. Good. 803, right? Good, very near to the answer. Any more thought from any of you?
I would like to compare it with the greenhouse effect what we have on Earth, that the carbon dioxide layer or whatever it is, the sun rays, the sunlight gets trapped and it raises the average temperature of the Earth. The similar process happens on Venus as well, because it has very dense atmosphere and the heat gets trapped, so it is hotter.
Okay, good, very good, good answer. I appreciate. So Venus is the hottest planet. So why it is the hottest? You know, on Earth, carbon dioxide, perhaps you might have heard it is 300, 400 ppm of carbon dioxide. But Venus has carbon dioxide almost 2 lakh times the carbon dioxide of Earth. So the Venus temperature is 470 degree, whereas Earth's average temperature is about 15 degrees centigrade. Right? So it is too much of the good thing. Like Earth requires some carbon dioxide or some greenhouse gas to maintain the 15 degree temperature. Otherwise, Earth would have been cooled. If there is no CO2 on the Earth, it could have been cooled by minus 18 degrees centigrade. So there's some carbon dioxide is required, but too much of carbon dioxide is not good. So what is happening? Why the greenhouse effect? So whenever the any energy from the sun comes to the Earth, it gets reflected and go back to the space. But these greenhouse gases, whatever has been identified by 6 or 7, those gases trap this energy and reflect back to the Earth back. So the Earth temperature goes up, and that is leading to the heating of the water, heating of the air, and lead to the global warming. So what is happening? Say, still we require some carbon dioxide, some water vapor, some methane in the Earth for at least keeping the temperature to the livable temperature. That is the average temperature of 15 degrees centigrade. If there is no CO2, no methane, no water vapor, then the temperature will be further reduced at the Earth because all the energy will get reflected. So some energy trap is required, but because of our industrial activity, the energy trap is much more than it is required, and that lead to the imbalance in the Earth atmosphere, and that lead to the increase of the temperature of the Earth. How much? Perhaps you will come to, say if you see this carbon dioxide trend, you will be surprised. I have taken the data from 1960 when I was born and 2020 today. So in these 60 years, the CO2 content in the atmosphere has gone up from 320 ppm parts per million CO2 equivalent. It is not CO2 to almost 420 ppm. So it is increased by almost 100 ppm in 60 years. So that is equivalent to almost 1% increase in power of the sun. So additional 1% power of the sun is getting retained on the Earth over a period of 60 years. And what is happening? Because of this, the global temperature is gradually increasing. How much? So you will be surprised. You will tell me that at one location we have got a negative temperature and one location we have got positive temperature. As such, the temperature is varying by almost 40-50 degree. What this 1 degree temperature will impact. But this 1 degree is the average of, as I told you, average of 30,000 points at several locations, and average temperature is increasing. That shows that water temperature increasing with sea temperature, ocean temperature is also increasing, and ambient temperature is also increasing, and that lead to the several climatic variation. And this is what we call global warming. So perhaps after looking at it, do you think that we should work on this? All of us have to work on this. Do you think we should work on this so that we restrict this temperature rise?
Yes, sir.
If we do not do it, what will happen?
This will continue to grow on the same pace, and one day all the glaciers will melt, and again there will be water all over the earth. And which has led, I have even read a theory that when there will be a high melting of these glaciers, there will be high evaporation. And when there will be high evaporation, it will ultimately result in high precipitation. And again, the high precipitation can give a chance to bring back the ice age.
Yeah. So now we are higher by almost 1 degree temperature. Okay. It is said that if we cross the 2 degree temperature rise as compared to the pre-industrial era, it will be irreversible. Means then perhaps the temperature rise will continue. Still, we have got some time to control this rise of temperature so that we reverse this whole greenhouse gas effect. So what are those greenhouse gases? Let us first look at it so that we can work on how we can reduce it. CO2, all we know, it is from the fossil fuel, transportation, coal, crude oil. This carbon dioxide is known, and a lot of things are being happened today in India and in the world. We'll come to that for the policy of India. Second is the methane. You know, methane is a naturally producing component from various animal, agriculture, natural gas system is added by the industrialization plus various waste what we are producing now. Industrial waste is also imparting a lot of methane in the system. Nitrogen oxide, yes, agricultural soil management, and because of the use of synthetic fertilizer, a lot of nitrogen oxide is getting produced from various furnaces, various heaters. It is being produced. HFCs like hydrofluorocarbon, that is that is refrigerant. It was being used, chlorofluorocarbon, now it is hydrofluorocarbon, but still it is greenhouse gas. It will not impact the ozone layer, but it is a greenhouse gas, and it major now it is coming out from the semiconductor manufacturing. PFC, perfluorocarbon, that is the aluminum production. SF6, that sulfur hexafluoride, that is from electrical transmission in transformer and everywhere. Various greases are used containing the SF6. Now it is banned. It is being replaced by the different material. Magnesium production also produce SF6. And apart from these 6, there is one more which is being identified, that is NF3, which is from various LCD industry. So these are all 7 greenhouse gases, but these greenhouse gases have got different impact on the weather. What is those impact? Suppose if you see the carbon dioxide and consider it as a 1, then every greenhouse gas has got the lifetime. So for that much life, it will remain in the atmosphere and it will have the impact on the global warming. Like methane is almost 12 times more life than carbon dioxide. But if you see perfluorocarbon, the one 50,000 years, so it doesn't die. It remains in the atmosphere and it continue doing the global warming. And that is defining the global warming potential, that in 100 years, how much will be the global warming potential of these greenhouse gases. If I consider carbon dioxide 1, then sulfur hexafluoride is 24,000. So 1 ppm of carbon dioxide and 24,000 ppm of sulfur hexafluoride will give me the same amount of global warming. And that is the reason if you go down, those greenhouse gases are getting banned, like sulfur SF6 containing grease used in the electrical system is now banned in India. So these a lot of things are taking place. But yes, whatever we have used, that will generate these type of greenhouse gases. Now I'll give you some guideline on the Paris Agreement. you know, we started with Montreal Protocol, then UFCCC in 1992, Kyoto Protocol in 1997, then some more such type of conference of parties have happened. But finally it happened in 2015. That was at Paris. And India also committed for the preventing the global warming. And now it is mandatory by almost all the countries. Almost 197 countries are signatory to this. So what India have committed? So all of them agreed that although more than 2 degree global warming will be reversible, but we must try to prevent it to or limit it to 1.5 degree centigrade rise. Out of that, as I shown you, 1 degree rise is already happened, right? So we have got only 0.5 degree margin now available for preventing the irreversible global warming. See, if you see India, where the India stands, India is the 4th largest greenhouse gas emitter, 7.3%. But India has got 1.7 ton CO2 equivalent per capita. As compared to US, it is almost 1/10. But still India have taken up a lot of challenges. And our commitment on the COP 2015 is we will reduce these emission intensity of the GDP by 30 to 35% from 2005 levels by 2030. Almost we have reduced by 20%. Now we have reached. So I am sure we'll be able to reach up to 33 to 35%. That is the emission intensity, means emission in terms of CO2 equivalent per $1 million of the GDP. What are the other commitment? We will generate 40% of our installed power from non-fossil sources. That is a renewable, like solar, like wind, like hydroelectric, like nuclear. And we will generate the additional carbon sink. You know what is the carbon sink available for us? We are polluting atmosphere a lot, but carbon sink available for us is the forest. On one side, we are cutting the forest, and other side, we want to create more and more this carbon sink. So we committed that we will generate 2.5 to 3 billion ton of CO2 carbon sink by 2030. And perhaps when you see the news that our forest cover is increased and all those things, and there are a lot of statutory requirement to provide the green belt, because you are a civil engineer, you may be asked to provide certain green belt. So those things are requirement for this commitment. So in India, from all which area the GHG emission is taking place, we discussed. One is energy, agriculture, industrial processes, waste, and we sink some of these CO2 emission in the land, forestry. So net emission is 1 plus 2 plus 3 plus 4 minus 5. But you will be surprised to know what is the share of this thing. We just now discussed about agriculture, but in India, the share of energy emission is almost 68%. That is the power generation, emission from power generation is 68%. Whereas industry emission is about 20%. Industry emission is the emission from non-power manufacturing. Then there are agricultural and food and land use about 8.71%, and waste is about 3.26%. So what all these energies are there? Building, transportation, lighting, weather control, street light, logistic, heating and cooling. So I have written building as a first. So that is where we have to focus. A lot of things are taking place. We'll see how the green building are now designed. But that is where we have to focus. And my suggestion to all of you, that you should start looking into this area to make sure that we make the green building in future. So there is a World Green Building Council as well as Indian Green Building Council. You know what is their voluntary commitment? Anybody knows? Green Building Council of the World and Green Building Council of India. So their commitment is by 2030, they will stop designing the normal building. They will be forced to design only the green building. We'll come to know what is the green building definition later, but they will design only green building by 2030. That is a voluntary commitment by the World Green Building Council. And by 2050, they have committed that all the building on the earth, they will convert into the green building by 2050. So whatever modification is required will be done. Then it will be converted to green building. So you have to keep in mind that this is what voluntary commitment by the world leaders, and that will also be applicable to India.
Hello, sir.
Yeah.
Sir, I have a doubt. Sir, zero net zero
Introduce
building or and green. Sir, 18 011. 18 011.
011. Okay. Yeah.
Sir, green energy building and net zero energy building are same or different?
Net zero energy building, green energy building means building is consuming energy which is produced by the renewable energy. Means it is buying the energy which is produced by someone else and consuming in their plant. Whereas net zero building is the building which produce energy. We'll come to that definition later, but just for your information, which produce energy, which has got all the energy efficient various equipment, and their net energy import is zero. Okay, so that is a net zero building. Let's go to, yeah. We'll come to that definition later, okay? Let's go to the India strategy toward the climate change. You know, we started from 2008 and then a lot of things has happened, and off late after 2015, we have seen a lot of advanced thing is getting happened because of the commitment of India. But we have got the three-step process. Number one is a mitigation. Our strategy is first is a mitigation. That is, we must use clean and efficient energy system, enhancing energy efficiency in the industries. A lot of action is being done. Perhaps we can have the additional session on that. Promoting waste to wealth and conversion. You might have seen several municipal corporations are now in that area. Sustainable transportation means now a lot of things are being talked about. Electrical vehicle or public transport and efficient transportation, network, plant afforestation means plant more and more trees so that you create some sink for the carbon. This is a mitigation. Adaptation means you know that it is going to happen, and if you want to live tomorrow, you are not going to stop the power plant because CO2 emission is taking place. You want to still live with that. So you have to improve your agriculture is one of the area which has got major impact on the climate change because of our requirement, Indian requirement. So we have to improve on our agricultural system. Although I have shown CO2 emission is only 8.7%. But there are several other areas, not only CO2, but other like NOx and like water requirement and all those things we need to relook it, and we should have some new agricultural policy. Coastal region and island management. So we are already working on disaster management, protecting biodiversity, state plans on climate change, knowledge management and the capacity building. So this is one of the area or one of the initiative for capacity building to make you aware so that you also start thinking over it. And whenever you go to field or go to work, perhaps this is the area of priority for the next generation. So what we are doing, say national fund is already being created. Cess on coal is already there. You know, if you want to use the coal, you have to pay some cess or some tax, because that tax money will be utilized for the carbon neutralization. Then there are several incentives for the low carbon growth. There are few subsidy which will be cut, and increased taxes on the fossil fuel. You might have seen petrol and diesel price are not reducing, even though crude oil price is reducing. But that is good for us because we are taking advantage of its price elasticity plus reduced CO2. And there are several initiatives we'll see at a later stage. What is the role of stakeholders? You are also stakeholder. I'm also stakeholder. Each and every person is a stakeholder in this initiative. And unless everyone work, it will not happen, right? So the role of every player is very critical. And while it is titled a global agenda, but in my opinion, it is a local agenda. Every stakeholder should be involved, starting from the world to the every individual. Just one question to you. Perhaps we have seen the, I don't want to show you only the dark face of the climate change, but looking at this, what is the first thing coming to your mind? Anything you are thinking about yourself, that how can you contribute on the climate change?
So we at an individual level,
on an individual level.
We at an individual level can prefer mass transport instead of going with our personal vehicles or going by foot if the distance is very little. So it can, these little steps can contribute in the emission of these harmful gases into the atmosphere, and hence
very good,
ultimately helping the climate.
Very good.
Plant more trees, consume, curtail the reduction in the resource uses. That is one of the most positive step towards the climate, helping in the climate change.
Excellent. Conserve the material.
Yes, definitely, sir.
Yeah. What else?
Have a eco-friendly technology use, cleaner production. That is one of the step for conservation of energy and climate change.
Okay. Anything else?
Sir, spread awareness in a rural area for family planning and educating girls, maybe reduce CO2 instead of childbirth and family planning in general.
Okay. We'll come to that later if time permit. What else? What is your commitment? I want to understand the commitment of the budding student who are future of India.
Sir, max use of public transportation.
Transportation. Okay. Transportation is, how much is the transportation?
Means no use of personal vehicle and use of public transportation more.
Great. So at least this commitment is, I'm happy to listen this commitment from some of you, but many of you are silent. So I believe that the rest of the people will agree to your commitment.
Yes, sir. I would like to give my commitment that I never used to leave a single grain of food in my thali since I can say since I was 4 years of age.
Yes, yes. You are very true. Because you know this food, people says that food is said whatever food we are taking is all okay, but 40% of the food is getting wasted, and that generate a lot of methane and carbon dioxide. So whatever is the waste is ultimately converted to methane and carbon dioxide. So the wastage is one of the area where global warming is taking place. What else?
Yes, commitment to save the tree.
Commitment to
Just to,
save.
yes, just to save one tree near the boundary to my home. I have shifted whole planning by 10 feet.
Ah, great. So that is the commitment. So if you have got this type of commitment, I don't think anything else. But still, there are a lot of areas. Maybe UK, if you see anywhere in your side, you might be losing a lot of energy, lot of fuel, might be creating a lot of other issues which create such type of emission. So some more thought from all of you.
Least
Sir.
use of air conditioners.
Least use of air conditioner. Okay.
Sir, as a structural designer, I am trying to make a eco-friendly structure or reusable concrete.
Exactly. Yes, that is a good thought. Very good thought. What else?
So at the engineering level, what we a few minutes back discussed the IGBC, whereas the IGBC says to make the green buildings. So the green buildings or the green offices, or they could be a good step because they permit natural light, they permit natural conditioning. Therefore, they can be a good step in preserving the climate.
That is there. Yes. Ultimately, you have to look for this type of design for green building, and you have to make it economical. Yes. So today, only the large companies are able to afford, and there is no policy or no rule for that. So the number of green building is not increasing the way we want. So you have to work on how you can make it more economical to have the green building. Consider the life cycle cost, because your capital investment might be higher, but your operating cost can be lower, and ultimately life cycle cost can be reduced. So you may have to convince your client on this area. But there are many more. We'll come to that, where you can save some emission. Okay, so next is a GHG protocol. All of you might be thinking that how the people are monitoring these carbon dioxide emission or various emission in the world. So there is a protocol, and it is very difficult to find out what is the GHG emission for one company or one country or one person. But there is a protocol, and that protocol define how much is your GHG footprint. So there are three scopes. Number one scope is a direct GHG emission, means whatever you are doing, whatever activity you are doing, and wherever you are consuming electricity or heat or steam or stationary or mobile combustion, these are all the direct GHG emission. Second is the indirect GHG emission, where you have to purchase certain energy, but you do not have the control on production of that energy. You have the control on the consumption of the energy, but you do not have control on the production. So that comes in a scope 2. And third is a scope 3, means if you are doing several activity, like college is doing the activity and students are coming from home or from the hostel to the college. So all of you said that we would prefer the public transport, or will prefer the pool transport. This is a good thing. So that is the scope 3 emission for the college. Such type of several activity which are related to the activity of the colleges or industry are scope 3, and it is very well captured by several companies, and they've identified what is their GHG emission level and how they are able to reduce on scope 1, scope 2, scope 3 emission. We will not go to this. So they work out what is based on the emission factor. There are a lot of documents available, some in free mode and some on the paid mode. And ultimately you find out what is your GHG footprint in kgs of CO2 equivalent per year. Okay, so ultimately we have to work on the GHG emission. But tell me, what should we do so that our carbon footprint is minimized? Should we use solar power? Should we use wind power? Should we use biopower? What should we do? Can anybody tell me?
So far, solar power is one of the cleanest energy to be adopted throughout the world. So I will go with solar power.
Okay, but you know how much energy we are consuming in production of solar panel? It's a highly energy intensive industry. And that is the reason why everybody cannot produce the solar panel that sells.
Sir,
Yes,
as
sir.
per my view, we should use maximum reusable or renewable energy as per circumstances. For example, we are living on mountains where wind velocity is higher. So we and in hot area we should use maximum solar energy.
Very good. So that one step forward, solar power to the power where the maximum power is available. But still you have to produce equipment, and in producing such type of equipment, you will be consuming a lot of energy, isn't it? So if you consider the life cycle cost,
I guess.
If you consider the life cycle cost of the power, there will be some impact on the CO2 footprint. It is not zero CO2 footprint, although power produces very negligible CO2 footprint. But if you consider the life cycle of the complete equipment, there will be some impact. What else? So you have seen that diagram where almost 70% was from power or energy sector, almost 20% from the industry, 8 to 9% from agriculture, and something from waste also. So one of the area which is said, that is the energy efficiency. If you improve the energy efficiency, it is a permanent availability of energy. And that, in my opinion, that is the area which is the least CO2 footprint option, where people can improve the efficiency of their operation and reduce the CO2 footprint. You know, today, if you increase the 10% efficiency of any of your equipment, and if every equipment 10% efficiency is increased, so overall CO2 footprint will be reduced by 10%, and that is almost equivalent to about 10 years of the CO2 generation. So the next stage, although we all say we should produce renewable power, wherever renewable power is more, we should produce. But the most important thing which is not focused right now, and all of us, we engineer have to focus on it. The common man may not be able to understand, but engineer have to focus on it, how we can improve the energy efficiency to reduce the CO2 footprint to the large extent. So now suppose if you are consuming 1 kilowatt or 1 unit power. So when you are consuming 1 unit power, how much power is generated by the power plant? It is said that power plant is generating 2 units of power for you to consume 1 unit of power. And that is proven fact. So where all those power is going? And if you see in India, a lot of things are happening to reduce these power losses. Number one is a generation, transmission, distribution, and usage. So in all these 3 areas, transmission, distribution, generation, 3 areas, there is a huge loss taking place. And transmission and distribution is about 5 to 25% of the power generated as on today. About 10 years back in Delhi, it was about 50%, but now it is about 6-7%. So that is where a lot of activities are being taken by the government in DISCOM, by the DISCOM, like distribution and distribution companies. And we are able to reduce these losses by about 5 to 25%. And that is the increase of energy efficiency. You know, how it is being done. Like one simple example, other major loss which is taking place, which is, what is this? Have you seen nearby your house? What is this equipment?
Transformer.
Yes.
Power station, sir.
This is the transformer that is nearby your house or nearby your substation, you might have seen. And you know how much energy we are losing in this transformer? There are several types of transformer like power transformer, distribution transformer. We are losing almost 6% of the total energy generated in the transformer. And that is the reason perhaps last 6 to 7 years, if you see your nearby house, the transformer might be, yeah. Transformer might be replaced by the government for improving the efficiency. Now high efficiency transformers are available and there is a plan by the government to replace the transformer by the high efficiency transformer. So why I'm showing this to you? Because when you design the building, you might be designing for such type of location and all those things. So at that time, you may have to think over it that whether you can go for the high efficiency transformer or not. Use of UPS. You know, all of you have got the laptop. So the laptop has got the UPS. This is just a symbolic, but there are several UPS being used in the industry for running their control station and various things. So this is one of the area where a lot of energy loss is taking place. Why? Because UPS is using the battery and inverter and all those things, which is all low efficiency equipment, and you are losing a lot of energy in the UPS. What else? Cell phone charger. Cell phone, you might be thinking cell phone charger, why I am talking about cell phone charger? It's a very small energy consumer. But if you see just a quantum, you know, this small unit, but a lot of us has got the habit of keeping the cell phone charger in the plug and keep the switch on. Like we have got 70 crores charger and is assuming 10% of the cell phone users are habitual of leaving charger in the plug with the switch on. So that is about 7 crores. And assuming that charger is left on for 10 hours for 365 days a year. So 10 hours a day, 365 days a year. You can imagine what is the loss of energy on a national level. 65,000 megawatt hour. That is 6.5 crore unit per year we are losing. So this is why I'm saying, so when you are showing the commitment, yes, you will do a lot of things. So these are the area where perhaps we have to think of that as a young engineer or the budding engineer or budding people, can we do something on saving of energy in this area? Although it looks very small, you might afford it, but ultimately nation have to pay. So this is a cell phone. So there are several such type of vampire energy in your house. This is what we call vampire energy. Just read the list and the energy consumed. If you just keep the power switch on in a standby mode, so you will be able to find the energy consumption by most of the house gadgets which are consuming energy unknowingly, and you are paying for this. And if you have the habit of switching off, perhaps you will be able to contribute on the national level, maybe DVD player or audio system or microwave, whatever electrical gadgets you are using. If you do not switch it off when you are not using, it will land into some or other energy consumption. And this is not my number, this is the number which is published by one company in US. So this is what we call vampire energy. We must turn it off, or we should not keep it in a standby mode. And that is where you can contribute immediately. Now, one more thing I would like to discuss with you. What is the difference in energy conservation and energy efficiency? Can anybody tell me? You might have heard several times, right? Energy conservation. Some people says improve the energy efficiency. What is the difference? Is there any difference, first of all?
Yes, sir.
Yeah, tell me.
I feel that efficiency is something that is related to work. That if there's a process which is going on, so how much we can save from that process. So that could be the efficiency related to the process. And whereas what I feel energy conservation is the total result or total outcome of the process, that we have saved something out of that efficiency. So that would be the conservation of that energy.
Any more thought? Any other student? Professors? So why I am defining these two terms, to make sure that whatever we are doing for our role for improving the global warming scenario are taken care of with some knowledge. Any other student?
Yes, sir.
Okay, 307.
So energy efficiency is that requires less energy to perform any function, and energy conservation is that result in use of less energy.
Okay, you are very near to the definition. Some more thought I am looking for.
Sir, I would like to add up to this that energy efficiency, for example, if we take an example of a pump. So if we pump certain amount of water with, let's say 10 watts, and if we could perform the same function in 8 watts, that means that we are getting energy efficient. This could be the energy efficiency. And
Okay.
whereas the conservation could be in terms of that we saved the 2 watts, that could be the conservation.
Now you are very near to that. So energy conservation is any action that result in use of less energy. Means if you turn off the switch off the light, that is energy conservation. If you switch off your AC, that is energy conservation. If you switch off all your vampire energy, that is energy conservation. But energy efficiency is the use of the technology that requires less energy to perform the same function. So simple example, few years back, LED bulb drive. So all the CFL and the other lights were replaced by LED bulb. So that was to give the similar amount of light with the lower energy, that is to improve the energy efficiency. Okay, So if you use some, I will come to that. You have to tell me whether that is example of energy conservation or energy efficiency. Okay. So now, say after these lot of conference of parties, India also have the National Action Plan on the climate change. So we have got the 8 mission, and out of 8 mission, one is a national mission for enhanced energy efficiency. So that is for to ensure the sustainable growth, because all of you know that if you continue using the energy the way we are using now at the same efficiency, perhaps the global warming will take place to almost 5 degrees centigrade. And it is not US is generating more CO2, so India will not face any penalty, or India is generating more carbon dioxide, so US will not face any penalty. It is not like that. It is all shared resources of Earth. So anyone violating the CO2 emission norm, everyone have to pay. So India also have the National Action Plan on climate change. One of them is the enhanced energy efficiency program, and that work for energy efficiency, equity, and environment. So that is national mission on the enhanced energy efficiency. That is National Action Plan on climate change. So nationally appropriate mitigation action. So whatever is appropriate, government policy will be related to these. Appropriate is very important word. It should not be like that we want to go for energy efficiency, so we are energy conservation, so we'll switch off the light and we'll work in a dark, and all those things is different thing. So nationally appropriate mitigation action we have to work out, because nobody is going to reduce their nobody is going to reduce their comfort. So there are 4 areas on which they are working, and we are all working. Okay. Number one is a perform, achieve, and trade. That is a mandatory energy saving target. Today, almost 1,500 industries are given this target, and if they do not achieve the target given by the government, they have to pay for it. So that reduced almost few thousand crores of the energy saving in last 5 to 6 years, almost 7 years. Second is the energy efficiency financing platform. You know, energy efficiency, everybody wants to improve, but the people do not have the money. So government is looking at it, that how to stimulate the funding for an energy efficiency project, so that people used to put the money, bank used to finance those people, and they get more energy efficient approach. Then third is a market transformation for energy efficiency. Just now we discussed about the Ujala LED bulb, like super energy efficient products, you know, 5-star, 4-star. Now we talk of inverter AC, and now ESL has come out with the scheme for super efficient ACs. So they will, just like Ujala will have some plan in the near future to replace the AC with some subsidy, so that overall energy consumption in the house and as well as various building is reduced. And framework for energy efficient economic development. So ultimately someone have to plan for all these things. So there is a FEED who is working on it, so that they continue pouring the fund, they continue pouring the technology, they continue improving the energy efficiency of not only power plant, for the industry, for household, for building, for hotel, for agriculture, everywhere. So these are the 4 pillars on which National Mission on Enhanced Energy Efficiency is working. And my suggestion to all of you, you know, the government policies are made with certain strategy. It is not like people are just magician bringing some policy into the picture and they start working. So this is the strategy, and if you see in future, whatever is new policy coming up by the government will be in this line. So try to correlate. So I'll skip this. There are Energy Conservation Act, norms for energy intensive industries, standards and labeling we know 1 star to 5 star. Then Energy Conservation Building Code has already come into picture or place. Demand side management is one of the major things which is done in last few years so that overall energy demand is reduced. And we are developing the energy professionals day in and day out. Even civil engineer also can be the energy professional. Civil engineer, mechanical engineer, chemical, electrical and chemical are always there. But mechanical, civil, instrumentation, they also can be the energy professional. So I'd like to give you some idea about Bureau of Energy Efficiency, what they are doing to reduce the overall energy consumption. You know, we were consuming almost 250 gigawatt of energy. Today we are at the level of about 200 gigawatt. So with a lot of development taking place, the overall energy generation is reducing. Why? Because of the improvement in energy efficiency, demand side management, and putting a lot of efforts by Bureau of Energy Efficiency, so that overall energy consumption of the people reduces. So star rating of the consumer durable. So always go for the higher star rating so that your overall energy footprint is reduced. Perform, achieve, trade. That is one of the very important program for reducing the energy consumption in the industries. Almost, as I said, 1,500 industries are now in that purview. It is a plan to increase it to almost 10,000. So anyone using more than certain energy have to be monitored by the Bureau of Energy Efficiency, and they have to meet the plan or target. How they are doing? So they consider it as a DC. What is DC? DC is so it is like one of the consumer. Okay, so BE established the baseline energy consumption. They set the target for them for next 3 years, and they were supposed to achieve the target. And if they do not achieve the target, they have to buy the ESCerts. So this is all market driven thing which is right now being practiced since last many years for these 1,500 companies. And suppose if I'm not able to achieve target, I have to buy ESCert. So this is I am telling you because, you know, this building also, this is for industry. Similarly, as I told you, the last one, commercial building and establishment. If you have got more than 500 ton of oil equivalent consumed in the particular building per year, it will be part of this DC, designated consumer, by the BEE. So if you are designing any building for more than 500 ton of oil equivalent per year, you have to design it with the most energy efficient gadgets. Now, what is the impact of PACT? Like, so the first is people started adopting the best technology available. Second is the abatement of wastage and leakage, because when you want to save, you have to avoid the wastage. Adoption of renewable energy, people are going for more and more renewable energy. Capacity building of energy auditors and agencies. Recycling, increase in R&D activities. Adoption of ISO 50001, that is energy management system by the PAT industries. So, you know, these are all these, say, one person cannot do anything. Similarly, only government cannot do anything. It is the combination of the people, industry, building, and the government. All these people, today I am seeing in India at least, we are working towards more and more energy efficient time. So any question now before we go to the building energy efficiency? Students?
Sir, you can proceed further.
Okay. So zero net energy building. So where I told you, World Green Building Council have decided that they will design only zero net energy building from 2030 and convert all commercial building to net zero energy building by 2050. So this is the voluntary declaration by the World Green Building Council, and Indian Green Building Council has already accepted it. So what is this net zero energy building? Can anybody say? We have discussed, but I want someone else to tell me. Any rough idea? Net zero energy building. Okay. So that is the building are those that are designed to have the lowest energy demand and high energy efficiency during its operation, and thereafter its energy requirement are made through renewable energy sources within that building premises. So that is the net zero. So you will be surprised that why are we talking? We cannot make such type of building. But yes, in India you will find how to make it. I'll show you some example later on. So there are two ways. Number one is a passive. Number two is active. Passive you must be knowing, because being a civil engineer, civil designer, you might have thought of like orientation of building and envelope of the building. But active is energy efficiency, as we discussed, in air conditioning, lighting, auxiliaries and appliances, or by the renewable energy off-site or on-site, right? So what is the passive? We'll talk about passive, and I want you to answer. So what is a passive approach? One is the orientation. So can anybody give me some example of the orientation, so that it lead to the less energy consumption in the building, in AC, lights, and other thing?
Basic building principles
Using
solar power.
Yes. Passive, no, we are talking of the orientation only. Solar
Passive,
power,
sir,
like
I would
power.
like.
Yeah.
Yes, a passive could be the basic building principles could be followed, that the orientation could be such that it receives the maximum sunlight, so that the need of artificial light could be eliminated. Also, it could be oriented in such a way that it will have the maximum wind flow or the cross ventilation, we can say, so that the need of the air conditioning, etc., could be eliminated. The example could be one of the tower in Gift City. They have followed all these norms of green building.
Excellent. Very good. I think I appreciate. Perhaps you have learned the subject, it seems.
We had a visit through IGBC to this Gift City.
Okay. So the minimize exposure on the west and southern facades, because that perhaps you will have a lot of lights also, lot of heat also. So this is what is minimum said for the passive oriented. Second is the envelope. So can anybody give me the example of the envelope? The envelope for the energy efficiency.
This could be in places where the temperature is very low. You can provide a certain jacketing or insulation kind of thing, which will give less heat energy could escape through it, so that they will not need much heaters, etc.
Yes, very good. So, but in India, that type of thing is in a very limited area. So, India, what type of envelope you are looking for? When you are looking for net zero energy building, what type of envelope you are looking for? So when you go for more sunlight, it will attract more heat. So you require more AC load, you know. So you have to find out how you can reduce it. So envelope is the external of the building, like glazing also, single glazing, double glazing, which lead to the reduction in the heat transfer coefficient. External block, we are using now AAC blocks in most of the high range building. So these are all the possible. Roof also, perhaps it is not applicable here, but in a cold country it is applicable. So there are several building envelope standard in the green building. Maybe if you can go through it, you will find a lot of ideas how you can reduce this the heat transfer to the building, as well as maximize the solar light. So how can you increase the, what are the other approach like HVAC or air conditioner, right? So in HVAC and air conditioner, what should we do so that our energy consumption is minimized? So number one is the smart AC saver or inverter AC or temperature measurement control by intelligent controller. That is the easiest thing we can do, right? Second is the periodic maintenance, cleaning, optimizing temperature, and establish maintenance program. And third is the design aspect, that is the variable refrigerant flow system or high efficiency compressor or combined refrigerant cooler with a heat pump, so that you are not losing the heat to cooling water or the air, you are utilizing that heat to heat somewhere else and reduce and eliminate reheating. And finally, now which is being practiced, and many of the people I know who have replaced their HVAC by the evaporative cooling in many of the places, and reduce ceiling height and use local cooling. So these are all the possible approach for reducing energy consumption in HVAC and air conditioner. Number two, lights and fans. LED lights we already discussed, right? Reduce excessive illumination, carry out, maximize the natural light, control of lighting with timer and sensors. You know, in many of these washroom or many of these conference room now, it is very widely used. Select ballast and lamp with the higher power factor, because you know these are all the non-linear load which lead to the lower power factor as well as very high harmonics, and which lead to the high energy consumption, because your energy is based on kVA, although you are paying on kWh, but kVA is the energy consumption. So lowering of fixture and use of task lighting. When you design the building, make use of task lighting and use of light color paint, carry out illumination survey to optimize the lighting system. And the one most important thing which is coming nowadays in market is the use of BLDC fan. We'll come to know. We'll see what is that BLDC fan. So one very now wherever in industry I go for some assessment audit, people have started using the natural light for lighting up their rooms. And this is by the light pipe. Very simple concept. It has got the light collector on the top of it, top of the building. There is a reflective system, and in the false ceiling, the light goes to the room. And this light collector is having some vacuum system, so that this is the vacuum, so that heat doesn't go in, only light goes in. So your room temperature also doesn't go up. And it will give you the light. I'll show you some picture. Will come later. It is not there in the presentation, but there are few pictures where in the room perhaps it is like as good as your LED lights. You will see. And this is now being practiced and used by many industries. In a workshop, in their administration building, this light pipe. Now BLDC fan, like brushless DC, direct current fan. So conventional fan we know, and BLDC fan which consume almost 50 to 60% power. And people give you the 5 years warranty, and but average cost is about 1.5 times the conventional cost. So I have seen if you are operating fan for almost 8 to 10 hours in a day, then BLDC fan will be economical, and people have started replacing from the conventional fan to the BLDC fan. So almost 50% of the energy conservation, energy efficiency improvement. Now there is one more government scheme. Almost a lot of people are using pumps and motors. So there is a scheme by EESL who give you some subsidy. And if you have got the motor between 0.75 to 75 kilowatt, it can be replaced by IE3 type of motor. That is efficient motor for the industrial purpose. So again, improving the efficiency at various industries are taking place. Now in other industries, there are a lot of initiatives like improving the power factor and improve the harmonic distortion, use of VFD for the electricity, motor efficiency improvement, fan, blower, pumps, compressors. These are all rotary equipment, their efficiency improvement, their flow control system, their drive and this gearbox, as well as what type of whether pulley and belt or the gearbox and various other energy efficiency measures are taken in the industry. Now these are all the single equipment, but the whole system like compressed air system, which includes the compressor and cooler and everything, chillers, refrigeration, cooling tower, DG sets, for each there are several measures are being taken at industry nowadays so that energy efficiency improves. And lastly, the largest guzzler of the energy, that is the furnace and boilers. And again, there are several measures so that efficiency is gradually increasing in the industry. So, example of the net zero or the carbon positive. Here I would like to reflect. Okay. Before that, if you have got any question, let us take up the question. Yeah.
Sir, one humble request.
Yeah.
Many of the students, they have the other classes at 6 o'clock. So it is requested that we should be slightly faster. Right?
Okay. Okay, sure. So I will take only a few minutes. So example of net zero or carbon positive. There is a building. Can anybody tell me the example of building? City you already mentioned, right? Any other example? Which one was the first net energy positive building? Okay, next is a company. You see, in India, there are few companies who are carbon positive. In the world, there are many companies. And the country, perhaps you might have heard about this country, I don't know. So even country can be carbon positive. So this is the first building in India, which is a net zero energy building. Can you tell me what is this building? This was the first building. That is the CII Sorabji Godrej Green Business Center, Hyderabad. Today there are almost 5,000 buildings in India which are almost nearer to the net and zero energy building. And this was the first platinum rated green building in India, net zero energy building. I happened to visit this building and I know this building is a standalone, no water, no energy, no other waste treatment outside, everything is done inside. They don't import energy, they don't import water, they don't send the waste. Everything is there inside, and almost 150 people are working there. Now, the company ITC is very well-known company, right? The whole company is a carbon positive company since last almost 13 years. You can see this trend. they were carbon generating in 2003-4, but from 2005-6 they are carbon positive. And how it happened? Because they have done the sequestration of whatever carbon dioxide they are generating in the fuel. And the carbon negative Bhutan. So whatever carbon they generate, they absorb in the trees, so that it is a totally carbon negative country. So that is also possible, and ultimately our target is to make sure that by 2050 the whole world is carbon zero. That is, and finally I would like to say there are Antarctica and other thing. We don't think these all things can melt, but we only care for ice cream, and we have to start looking at this type of thing. Thank you.
Thank you very much, sir.
Now, I would request Professor Neha ma'am to give vote of thanks.
Sir, with concluding remarks, I thank on behalf of Women Development Cell, Civil Engineering Department, Structural Engineering Department, and BVM Engineering as a whole for sparing your valuable time and highlighting about the different sectors where energy can be saved or it can be managed, thereby reducing the greenhouse gas emission and saving the climate change and environment as a whole. Thank you very much, sir, for your valuable contribution, and I hope whenever our students they are working on the project for energy conservation or management, you will be one of the mentor and you will spare your valuable time and share your experience with our students. Thank you very much, sir. Thank you again.
Sure, Dr. Reshma, it will be my pleasure. I also enjoyed with some of the feedback given by student, and I also am thankful because now to develop the capability on energy conservation and climate change in the various colleges, one of my Sumoto initiative, and it was a great talking to the people, and I will help this all the student as and when they require. I will be available. Okay.
Thank you. Thank you very much, sir. Again, once again.
Okay. My pleasure.
Thank you, sir.
Pleasure.
Thank you very much, everyone, for joining us today. I would also thank our faculty coordinators, Dr. Reshma Patel ma'am, Professor Neha Patel ma'am, and Manali Shah ma'am for supporting us. Thank you very much, everyone.
Bhargavi, can I take a 2 minutes?
Yes, ma'am. Sure.
Hello, Miss Ma'am. Yes. As it is our concluding seminar of a webinar series of Insight of Construction Project and Management.
Madam, your mic is muted.
Ma'am, your mic is muted.
Okay, sir. Am I audible?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
As this is a concluding webinar of webinar series of Insight of Construction Project Management. There are several people who have associated with us for the successful of this particular webinar series. So I must thank to all of them. Very first thing, I am very much thankful to Dr. Ayan Patel and Dr. Principal BVM Engineering College and Dr. Desai, convener of Women Development Cell, and Dr. LB Jala and Dr. A.K. Verma sir, HOD of Civil and Structure Department for constant encouragement and support them. Without them, this webinar series will not be possible. We are very much thankful to all the coordinators, women faculty coordinators of Civil and Structure Department who has helped us to arrange different webinars in the series ICPM 2020. It is my heartiest thankful to all TechUK officials for providing all kind of assistance and Mr. Professor Dhaval Parmar who has constantly give us support for Microsoft Office team. Dear participant who has taken the wholehearted participation in the series, without them this program won't be successful. And most important, I am thankful to student coordinator Arya, Venu, Hetvi, Hani, Preetam, Bhargavi and Riddhi Jain from the GC Baswada. And I am thankful to all the people who has helped us directly and indirectly for the completion of this webinar series. So thank you all. Bhargavi,
Yes, ma'am.
you can conclude this webinar.
Yes, ma'am. I again thank all the participants. Now you can leave, and don't forget to fill the feedback form as it is essential for your certificates and our data also. So yes, you may leave now.